Hello everyone. Today I will start with self-learning, the Microsoft Azure Data Fundamentals certificate. Uh, it's DP 900. I didn't learn it before. I'm starting to learn it, and I will try to learn it verbally to send more information and as a good learning experience for myself. And this video will be available online for anyone to be able to use, maybe learn alongside me. If it could help anyone, it would be good for me. I don't mind. Okay, so basically this exam will be 45 minutes. Will be a 45 minutes exam, and it's not an open book exam. You can schedule it through Pearson. The price varies through different regions. So it's Microsoft Azure Data Fundamentals. It has four main learning paths. Microsoft Azure Data Fundamentals explore core data concepts. Microsoft Azure Data Fundamentals explore relational data in Azure. Explore non-relational data in Azure. Explore data analytics in Azure. Okay. These are the four main learning paths that we need to finish. It's relatively small, two modules, four, six, and nine modules in total. Okay, now we could get it has a 25% for each part of the modules. Each module has almost 25% from the last scoring, from the last scoring, from the last score. And it's relatively small, as we can see, 59 minutes, 1 hour 27 minutes, 1 hour 26 minutes, and 2 hours and 7 minutes. Okay, so let's start with the first with the first learning path. It has two modules. The first one would be exploring core data concepts, and the other one would be exploring data roles and services. All right. Exploring core data concepts. Uh, we learn that in the past time, data is the most important aspect in our lives. That the huge amounts of data are produced all the time, and data is now easier to collect and cheaper to store compared to previously. Data solutions include software technologies and platforms that help facilitate the collection, analysis, and storage of valuable information. So basically, we're responsible for storing information, large amounts of information. It's basically related to businesses. Businesses would like to store their information somewhere to be safe and secure, and to prevent any fatalities and any big problems that would ruin the revenues. And something to help them make larger profits. Faster systems, redundant systems, all the time up systems, high SLAs. That's basically the idea of the storing data on the cloud. And here we'll learn about storing and representing the data, and how to deal with data workloads, as workloads differ in managing them. Some workloads are large and others are smaller, and how to know if something is fit enough if something is fit for our scope. Just to learn more about how much is needed for the scope for our scope for the businesses that we're trying to run. Now, we'll need to identify the data formats. That is a collection of facts such as numbers, descriptions, and observations used to record information. Data structures in which this data is organized often represent entities that are important to an organization, such as customers, products, sales orders, and so on. Each entity typically has one or more attributes or characteristics. For example, a customer might have a name, an address, a phone number, and so on. It's basically talking about what something when we're trying to define something, a human being has several arms. Okay, a human being in a database or information about a certain human would be his name, his address, his phone number, his gender. Uh, okay, so certain places might need different information about this certain person. So the certain people have like different names, emails, phone numbers, and several other things. Now, data can be images, can be and so the first type of data so we have three types of data mainly: structured, semi-structured, or unstructured. Now, when we say structured data, all the data has the same attributes. Let's read more about structured data. Structured data is this data that adheres to a fixed schema. So all of the data has the same fields or properties. Most commonly, the schema for structured data entities is tabular. Now, the data is represented in a table or more than one table. It consists of several rows to represent each person. For example, if we have a table for people, each row represents a certain person. Now we're looking here, for example, a customer. We're having customer and product entities. Each customer has his own ID, first name, last name, email, and address. Tain and Imbul, we have two instances, two customers. And we have here products. Each product has an ID, name, and the price. We have three instances of products. Now, this is the structured data. Each customer has the same attributes, and each attribute must be filled, or it can be some information can be missing, but that's not our issue right now. Basically, it's just that instances of the same information for each and every customer. So is for the products. Uh, Structured data is often stored in a database in which multiple tables can reference one another by using key values in a relational model, which we'll explore in a more depth later. Now, something is called key values. Like key values is the ID, something that's not allowed to be repeated in each instance. For example, if you have 100 instances, 1000, 1 million instance, the ID shouldn't repeat itself at all. That's not allowed. If an ID repeats itself, nah, then the key value is ruined. So we basically need something unique to define our key values. So is the products. If I have a million products, no two products would have the same ID. Semi-structured data. Now that was the structured data. Now each data has an ID, first name, last name, email, and address, for example, and each one has several instances. Now, when we're talking semi-structured data, is information that has some structure, but which allows for some variation between entity instances. For example, while most customers may have an email address, some might have email addresses and some might have none at all. Now, for example, I have a customer and that customer has two emails. He could list them for me, but I don't have uh, a special column for another email. So while another customer might have no emails at all. So I'll need to use semi-structured data. Semi-structured data is usually formatted using JSON. We use JavaScript object notation, which is JSON, which stands for JavaScript object notation. The example below shows a pair of JSON documents that represent customer information. Each customer document includes address, contact information, but the specific fields vary between customers. So basically, now I have two customers here, customer one, customer two. The first customer, first name, last name, address, and the second one has the same things. The same things. The address ends here. Both of them have addresses. But as we can see here in the contact, we have one email. While the customer number one in the contact, he has a phone number and an address. So it's structured, it's well structured. We can see there's a first name, last name, address. It's structured as we have several columns to look after and that we need to fill. But sometimes some data I need to have multiple instances of the same thing. Here we can see it's the contact. For example, we have two contact information and while the other customer has one contact information. We have a note here. JSON is just one of many ways in which semi-structured data can be represented. The point here is not to provide a detailed examination of JSON syntax, but rather to illustrate the flexible nature of semi-structured data representations. We can represent unstructured data in many several ways, but we looked only at the JSON part, only at the JSON format. There are several other formats, but we're just giving an example here. And the last kind of data, we have the unstructured data. Unstructured data, not all data is structured. Now, when we think about it, each in our daily lives, yeah, we have some structure, but some other things can't be under the name of structured data. For example, documents, images, audio, video data, and binary files might not have a specific structure. This kind of data is referred to as unstructured data. If I have an image, a video, an audio, anything, documents, these are unstructured data. I need to store them somewhere, but they don't come under the under the first two formats, the structured and the unstructured data. Now let's look at the last unstructured. Let's know more about it. Now, where do we store the data? Organizations typically store data in structured, semi-structured, or unstructured format. As we mentioned before, we have three types of formats: structured, semi-structured, or unstructured. To record details of entities, for example, customer and products, which we mentioned, specific events such as sales transactions or other information in documents, images, and other formats. The stored data can then be retrieved for analysis and reporting later. There are two broad categories of data stored in common: file stores and databases. Now, we have two categories for storing data. We can store them in databases and we can store them in file stores. We'll explore both of these types of stores in subsequent topics.